In this video, I'm going to focus on the mechanical energies. First, what is a mechanical energy? Know that mechanical energy is not a type, rather it is a classification of all of the energies related to motion and position. At this level of physics, there are three of them that we're going to really dive into. That would be kinetic energy, gravitational energy, and elastic energy. Let's look back at our energy definition. It states that energy is a substance-like quantity with the capacity to cause change. So as I explain each of the three mechanical energies, I'll be focused on the changes that each can cause. Let's look at kinetic energy. You have two variable options. You can choose capital K for kinetic or EK for energy kinetic. This is defined as the energy of motion. If something is in motion, it has kinetic energy. If something is sitting still, it does not. Here we're looking at a ball flying to the right through the air. Because it's moving, it has kinetic energy. And because it has kinetic energy, we can use that up to cause a change in something else. Maybe the change we want to cause is the breaking of this window. So the ball hits the window, and in our first trial, the window didn't break. So the question here is, what can we change about the ball while it's flying through the air to have a better chance of breaking the window and cause a greater change? First thing we can change is the mass of the ball. A larger ball will have a better chance of breaking the window, and also we would want it traveling faster through the air. So with a small mass and small velocity, the window doesn't break. With a bigger mass and a larger velocity, we'd have a better chance. So know that the factors for determining kinetic energy will be the mass of the object and the velocity it moves with. Next, we need to talk about the term potential energy. This is only applied to certain objects. Imagine we're looking at an object that is at rest. We grab the object and pull it away from where it's resting, and when we release it, these objects go back to where they were resting on their own. So these objects are said to have the potential to return upon releasing them. Of our three mechanical energies, two of them can be classified as potential energies. Gravitational works that way, also elastic. Let me give you some examples. Starting with gravitational potential energy, we're looking at a ball at rest on the ground at position 1. That's where it wants to be at rest. We have grabbed the object and pulled it upwards at moment 2. When we release it at moment 2, it has the potential to fall back down in moment 3 on its own. We don't have to throw it or push it downwards. So we would say that the object has a potential energy at moment 2 because it will return to its resting location on its own. Here we're looking at a spring tied to a vertical pole. The spring is at its natural length in moment 1 and isn't trying to do anything. We have grabbed the spring and pulled it to the right at moment 2, so now it has the potential to snap back to the left upon releasing it, and in moment 3 it has snapped back to its natural length. So the spring has a potential energy at moment 2 as it's waiting to return to where it was resting. Let's dive deeper into gravitational potential energy. Two variable options. Know that capital U stands for potential, so UG represents gravitational potential, maybe EG for gravitational energy. This is the energy of vertical position. So here we're looking at a ball held in place above a person's foot. Because it has a vertical position above the foot, it has the potential to fall downward when released. And maybe the change we want to cause is how badly the person's foot bruises or how much it hurts. So we drop it the first time, hits the foot, it didn't hurt that bad. What can we change about the ball to make it hurt more? Well, first thing we could change is the mass of it. A heavier ball will hurt more. We can change the drop height. That gives it more time to accelerate, and therefore it will be moving faster at the time it strikes the foot. And then hypothetically, we can also change the planet that we perform this on. If we were on a more massive planet with a stronger gravitational field, the object would accelerate downward faster. So the factors for gravitational potential are mass, height, and gravity. Finally, let's look at elastic potential energy. Again, two variable options. You can go with US for potential for a spring, or EE for elastic energy. This is the energy stored in a stretched or compressed elastic material. Know that elastic materials are stretchy, and it's not enough just to have one. We need to stretch it or compress it from its natural length. Here we're using a rubber band, which is stretchy. We have pulled it to the left, and while we're holding it, it has the potential to snap back to the right on its own. When we release the rubber band, it can convert its elastic potential energy into a change, and maybe the change we want to cause is how badly this person's hand hurts or leaves a red mark when the rubber band strikes it. All right, we release the rubber band, it hits the hand, it didn't hurt that bad. What can we do differently to cause a greater change and make it hurt more? One thing we can do is to use a different rubber band altogether. The thickness of it and the type of material it's made out of would both factor in to the starting elastic potential energy it has. Also, we can pull it back further before releasing it. So the factors for elastic potential energy would be the stretch distance, represented by the variable x, and the elasticity, or something related to the type of stretchy material we're using, that will be represented by the variable k.